So now our presenter is from India, Chander, Devgun, and this is our first internet. Actually, I think I better turn on. Okay, I have one detail to take care of here, and that is to connect the video projector. Okay, and then we'll make sure that we can see Chander's slide here in a second. Okay, can somebody kill the lights in the back there? Okay. So Chander, are you there?
Yeah.
Okay, we're ready. You can start.
You are seeing the desktop over there? Is
Yeah.
it coming? Okay. Hello?
Hello.
Yeah, is it coming okay, the desktop?
We can hear.
And what about the screen? The whole thing is coming over there?
Yes, we see astronomy teaching in India.
Yeah. Okay, so good evening everybody there, and it's actually good morning over here because right now in India the time is 2:30 a.m. and I'm very thankful to Ellen and Patrick to give me time on such a short notice to present something which we do in India about astronomy and global hands-on universe. I have been seeing this website quite a long time, and this is the first time I'm addressing you all people out there about what we do in India. We are basically a bunch of astronomers, amateur astronomers, who have formed this non-government organization called SPACE. Its full form is Science Popularization Association of Communicators and Educators. And through this NGO, we work in different schools all across the country to promote astronomy as a science and also as a hands-on tools for learning the day-to-day science among the students. We cater to the age group of students who are basically in standard 6 to 8 standard. We have curriculum for those students, and we are working on a basis of the Constitution of India, in which they say that it shall be the duty of every citizen of India to develop the scientific temper, because the times now we actually need scientific temper among the kids, as most of them are not questioning any further. When they are being taught science, they are basically being taught in a classroom scenario where it's only a blackboard and whatever teacher says to them, they will accept it. But in science, we know that questioning is very important. So we actually are inculcating the art of reasoning among the students, and we are doing this thing with the help of the modern day technology as well as the technology which was available 100 years back. Now, you see on the screen, we are doing learning science by experiencing it. We have the telescopes out there with kids seeing the sun through the H-alpha filter there, and then the kids out there, they are doing the shortest shadow experiment with the gnomons developed by us and finding the local noon and finding the north over there. Same thing happening in the schools. We are doing it outside the school as well as inside the schools. And then we have the night sessions in which we take out kids out of the city, because in all the big cities over here, it's a worldwide phenomena that light pollution is there in the cities, and you can actually count the number of stars in your fingers. So what we do, we take them outside the cities around 100 kilometers away from the main city and show them the night sky, which they should have seen in the real, not through the books or not through the internet or the TV. And then we have kids doing experiments on their own in science fairs, which we arrange in different schools out there. We have been in Delhi. We have a very good observatory called Jantar Mantar, which is basically an observatory made out of the stone to watch the sun and the moon through the shadow of the instruments over there. So in this slide, you can see actually students out there measuring the shadow formed by the moon and checking the local noon over there. And then you can see in this slide, a student has made his own small sundial over there, with which they are finding the local noon and finding the times in different cities. And then here one of our educators are standing as the gnomon stick over there. It's very difficult for us to keep the kids standing for longer duration. So we use the educator to just check the shadow formed and what's the sun angle over there. And these are the different things we have developed here in India, just to show them how the science can be done with a very small and very simple instrument. They don't have to have anything which is high-tech, and basically when they think about the science, they think that science means using very high-tech instruments. So that actually takes the science away from them. So now what we do, we have a very small kit developed for them, which we call the astronomy kit. The gnomon over there is an example of that. They use this to find the local shadow and the north and so many things with this gnomon. About taking astronomy to the students, as I was telling you that we cater to primarily to the classes 6 to 8 standards. There we have done so many projects in the past in which we have involved those students to learn about the science and astronomy. Because astronomy, we say, is the mother of all sciences. So if they learn astronomy, they eventually learn the different aspects of science in a very interesting way. I'll just show you some of the projects which we have done, and after that I'll give you the details. We did a project called Vamana project, that was basically the Venus Transit 2004. And then whatever time zone we are using in India, so nobody has actually seen that place where exactly that line of 82.5 degrees east goes through. So we named that project as Khoj, which in Hindi language means to investigate and to discover. So that was the search for the Greenwich of India. And HelioTC is one of our projects in which we are observing the total solar eclipses wherever they are happening in the world. We have taken students to Turkey in 2006, in Russia in 2008, and in China in 2009 to show them the eclipse. And then, because the light pollution is a kind of a curse for every astronomer all across the world, so we are doing a project called Project Dark Skies, in which we are quantifying the light pollution levels in the different cities of India. We have been working with Patrick Miller in ISAC for the last 2 years, doing these astronomy All India Asteroid Search campaigns, in which we are involving students across India to search for the asteroids. And we are also running this program successfully right now. Phase is also, and second phase has been going on. In the Vamana project, that means the Venus Transit 2004, we did the measurement of the Earth's astronomical unit, the distance from the Earth to the Sun, taking the context of Indian flavor in it. One of the incarnation of Lord Vishnu, in which he had actually traversed the whole universe in 3 steps. So we used that kind of analogy to show our students that if we want to know the astronomy unit, we can first know where exactly we are placed on the Earth, and then by measuring the Venus elongation in the sky before the Venus transit, we measured the Earth and Venus distance, and then finally observing the Venus transit, we measured the 1 AU within about 5% of accuracy, and there were around 2,500 students all across the India who were connected to us in this project, in which they actually measured the Venus transit across the sun. And in the project Khoj, as I was telling you, that we actually went to a place where the 82.5 degree longitude line is passing through, which is our Indian Standard Time. That's the Indian Standard Timeline. Nobody has ever gone there actually to see that place. And the idea came from the Confluence program, in which people were using the GPS to find the crossing of the latitude and longitude lines. So initially we did a few of the crossings across in India. We did around 15 points in India where the lines of longitude and latitude were crossing. And then we took our students to exact point of 82.5 degrees, that's in near Allahabad in India. There they, with the help of the GPS, they found out that place where the IST timeline was going on. And this project of ours, in which we had students doing all this, was mentioned in one of the books by the Oxford University Press, in which how the astronomy and geography can be taught outside the classroom. That was mentioned over there. Our project had a special mention there, when we take the kids out to exact location of the longitude and latitude crossings. And you can see in this slide over there, we had placed a kind of a watch over there on that timeline, where people can actually see that's the place of which time India has been using throughout the length and the breadth of India. Because in India we have got only one time zone, and we have got that line at 82.5 degrees. So with the help of this project, which we called Project Khoj, students could actually relate the geography and astronomy with each other. They came to know what their longitude and latitude exactly are, and then they found out that line over there. The HelioDC project, in which it's basically the journey to the sun. We have been observing the total solar eclipses with the kids and the students through our online competition since 2006. We have covered the total solar eclipse from the land, from the water in the cruise, and in the sky when we ran the first flight during the eclipse in India. That was in 2009, 22nd of July eclipse. When we had monsoon season here in India, it's totally cloudy out here, and the sun was low on the horizon, but the people in the plane, they actually saw that eclipse 41,000 feet from the ground, and that was the first time we did that ever in India. And you can see the plane over there with the fellow passengers who went there to chase the eclipse from there. And during the 2010 annular eclipse, we were the only people in the northern limit of the limb of the annularity, where we actually made a video of the Bailey's beads over there. And there was only one guy, I think Gary Nugent, who did it from the southern part of it. So kids with us who were in the class 6 to 8, they actually were with us during that project, in which we shot this Bailey bead phenomena over there. And in India, in 2009, the solar eclipse, you can see the crowd over there waiting to see the eclipse happen. And this is some kind of a journey we have taken from people not going outside their houses to see the eclipse, and here thousands and thousands of people standing outside waiting for the eclipse to happen. So that's the change we have brought through our astronomy teaching among the kids and among the masses, that so many people can come out, and despite the superstitions about the eclipses, there were so many out there, in terms of thousands out there, who wanted to see the eclipse. And while seeing the eclipse, we made students to actually do some science out of it. You can see the, one prominence over there, and students actually determined the pixels from that prominence over there, and they found that how big that prominence is by measuring the diameter of the sun and the earth through the pixels. You can see on the right hand corner, just below the space logo, the size of the earth over there in the blue dot and the prominence over there. So we expose the kids to various techniques of having science out of the simple pictures out there. And Project Dark Skies is a project which we have been doing for the last 3 years, in which we are quantifying the light pollution levels in the metro cities all across the country. And we have been participating in the Great Worldwide Star Count in 2010 and Globe at Night last year and this year also. Connie must be knowing that there are so many more number of observations from India, because we have been instructing people as a citizen astronomer to go out and watch the night sky and see how many stars are there. And another thing we did in the Great Worldwide Star Count is that we actually, here you can see the crowd over there using a pipe method to know the number of stars. And in the Great Worldwide Star Count, we made the activity guide in our national language, that is Hindi, so that more and more number of people can actually get hold of the astronomy to them. Because in India, English is a very common language out here. Most of the higher studies are being done in English, but the language of the common people out here, of a lay person, is the national language, that is Hindi. So we offered to make this guide in Hindi, and then we had this guide in Hindi, and we are also working on other guides, so that more and more number of people can actually join the astronomy teaching which we have been done by us. Now we have been working with Patrick Miller in the All India Asteroid Search campaign since the last year. And last year also we had one major discovery by the students in India. That was the first time. And here you can see we have been training the students, teachers also and students also, because students are the one who are actually going to run those programs out there. And these campaign training workshops have been so successful. Patrick is a testimony to that, because in the last phase, you can see here in the American Center, we are doing those programs out there. And that's the first asteroid discovery last year done by students. That was the first main belt asteroid discovery here in India by the students of 11th standard. So that was something which nobody would have thought of doing that in India earlier. And this year also in the phase 1, which ended a few months back, we have 2 provisional discoveries and 21 preliminary discoveries of the main belt asteroids, 7 NEO confirmation, and around 165 NEO observation by the students of 6th standard onwards. So that kind of a training we are giving to the students out here, and we are hoping that more and more number of students, in fact I was talking to Patrick Miller to increase the number of schools to us, so that we run the campaign in schools from the far reaches of India. Right now we are working with around 60 schools for the asteroid search campaign. 30 schools have done it, and 30 schools are in process of discovering new and new asteroids. So this program, which is basically a part of the Hands-on Universe, has been quite a success here in India. Before 2010, nobody was actually looking for asteroids in India apart from the graduate and the postgraduate level students over there. But we brought the concept of real science, sharing the data, real data from observatories, to the students who are just beginning to know about astronomy, and that has been very successful. And recently we have just finished a pilot project with Isaac, with Patrick Miller, of controlling the Northwood Observatory, Ironwood North Observatory, and students from here on 16th and 17th of July this month, they actually control the telescope from there, from Delhi itself, in a telescope in Texas, and it also has been quite a successful campaign with those students, and we hope to do this campaign fully in Global Astronomy Month 2012, where we will involve around 80 schools, and they will be taking these pictures, controlling the telescope in the real time from here and doing it. And because telescope for us is a main thing whenever we try to do astronomy, and to generate the interest of students in astronomy, one method is to show them the object through the telescope, and the another method is let them control the telescope on the internet and get the image in the real time. There are telescopes which gives you the opportunity to click, but in this particular project with Isaac, students were actually controlling the telescope in the real time, and they were very excited about it, as they were actually filling in what exposure to take, and they could know how the telescope is slewing towards the object and how is it focusing and how the different RGB filters are being put on. So they were very much interested in that, and as you can see from the pictures which they have taken, so it has been quite a successful pilot run, and I hope that with Patrick we'll do this in April 2012, and that would be a successful thing. All in all, we have been doing astronomy with the kids here in India for quite a long time. It's been around 10 years now in a professional setup. Before that, we were doing it as a volunteer, because we all are basically amateur astronomers. So to combine the effort which we are doing right now with the global hand-on universe, so that more and more students in India can actually have access to the real-time data as well as to the latest software and the technologies available. So here, right now I can show you where exactly we are located all across the India. So we can actually have a pan-Indian approach, in which whatever project we want to do, we can involve the students from all across the India to make that project successful. We have been doing the Eratosthenes experiment every year, and almost 20 to 30,000 kids, they have been doing this each and every summer solstice day to find the diameter and the circumference of the Earth with a simple gnomon which we have made. And I would end my presentation over there by thanking once again Alan Gold and Patrick Miller. They have given me this opportunity at such a short notice, and I would like to join hands with the Global Hands-On Universe so that we can promote astronomy more and more in India, because this is the emerging time and the students are going away from the science. To take them back to the science, we need one science which is very simple to understand, and that is astronomy, because astronomy, in my view, has got the biggest lab out there. Nobody can take away the sun from you. You can observe the sun as much as a professional astronomer can observe. So astronomy is an open lab for us. The universe is an open lab for us, and we should give the opportunity to all the kids who basically will be the future scientists for us in years to come, and expose them to astronomy and do the things over there. I once again thank you all for being a very patient hearer who listen to my presentation over there. We have a website called space-india.org, and I can be reached at this address at cb@space-india.org. Thank you once again, and thank you, Alan, for giving me this opportunity.
Thank you. Do we have, are there any questions? You might want to, so that,
Patrick's on his way. Chander, let me say something first. This is really super. This is Carl Pennypacker. Also, I just want to let you know there's eclipse in northern Australia 2012 that some HOU people are thinking about going to. And then also in 2017 in the United States, there's a big one. That's a big total.
Yeah.
So let's start preparing for those together, okay?
Yeah.
Any other questions?
And I would like to add one more point over there. We have been working on the Venus Transit 2012 in a very big way so that we can involve more number of people this time, because it has been 8 years since we started that Venus Transit thing. So now we are involving more and more number of schools over there in which they can actually measure the fundamental unit, which we say the one astronomical unit, and involves other students into it.
Okay, Patrick has a message for you, and I think you can.
Okay.
Can you see Patrick here?
I can see Patrick here. I can see you as well as Patrick.
Hello, Chander.
Hi, Patrick.
Do you recall during the first phase of the current All India campaign that you had two students from the Balbardi Public Schools in New Delhi who made a provisional discovery?
Yeah.
That was, I guess, Mr. Shalala and Mr. Agarwal.
Yeah.
They discovered, the provisional discovery was 2011 MV9.
Yeah.
The Minor Planet Center yesterday announced that that was a Trojan in orbit in one of the Lagrangian points of Jupiter. This is the first time in the history of Isaac that any students have discovered a Trojan. So congratulations.
That's great. Yeah, that's great. Congratulations to you. Because of you, we were able to do that.
Here's a view of the rest of our workshop, and that's the eastern half. Actually, I don't know which direction it is. Yeah.
Okay.
And then there's me, and here's the other half.
Hey.
Okay, thank you so much. That was really, really good.
Yeah. Thank you. Yeah, it has been quite an experience for me to talk to you people from so many thousands of kilometers away from you, but still I feel like sitting over there and being in the conference.
Okay, I think we're on schedule, actually, amazingly enough. And the next presenter then will be Mark. And you put it right there, and we'll connect. We need to actually, let me stop this recording. We have to take a couple of minutes just to switch technical issues here. Where did my sharing desktop go? Okay, here.
Something big drops always a good idea. I brought the universe.
Here's your connect.
I have to ask all the question. Is this thing going to work? Let's try. Yeah, that's a good kind of.
Something weird is happening on my computer.
Teach my computers to. Yeah. Good. Okay.
In order to get our the other people connected, we need to have you log in to ReadyTalk.
Okay. Okay.
Only problem is I seem to have lost control of my. That you're controlling? Can you?
Yeah, how do I ready talk? Yeah, good. How do I get there?
Maybe.
How do I get there?
Stop sharing. You. Yeah, we were seeing him.
How do I get? Is it this thing?
Correct.
Yeah. So log in with 6435082.
643.
5082.
Is that what?
Yeah, I have control now. I don't know how that happened. I mean, control returned to normal. That was very strange. But thanks for noticing that. Otherwise, it would have been.
Put any name there?
Yeah, just put your name, just first name, whatever.
I wanted to reboot my computer and map if I wanted to stop the session.
I don't know. Somehow you got more control than you should have had. Okay, you're in.
I'm in.
Yes. So now I can. Wait. Did you log in as me?
Yes.
Okay. Well, I'm going to promote.
Oh, that's all right.
I'm going to promote me to the co-presenter.
Actually, no, I logged in as me, not as you.
Now you should see a signal on your screen saying that you're gonna. Yeah, it's gonna. You're being promoted to presenter. It's loading some stuff on your computer. No. Don't press that. Don't press that.
Okay.
Just wait for it to load its thing, and then it'll ask you if it's okay for you to share your computer.
Okay. Now I may better go back to having one screen because I don't know if ReadyTalk is happy with two screens. With two screens, it shows something different.
Probably not. Yeah. Yes, allow that. Now, and that will make you co-presenter.
Not sure. Yeah, I don't know if the computer will blow up. You never know with these.
It takes a second for it to finish connecting, so don't worry about it.
To blow up?
Don't worry yet. Yeah.
Computer's like to blow up.
Okay, you are a co-presenter. Now, at the top of your screen, when it comes back to you, you will see.
See an overload, yeah.
Share desktop. See that at the top? Oh, you are sharing your.
Here?
Is that your? Wait, no, that's my desktop. Is that your desktop? I can't.
Press share desktop. And I just sit there.
There you are. Yeah, you're on.
Oh, man.
Yeah.
Yeah.
Okay, you're on. But wait a minute. Hold on one second. I want to record this. Okay, and then we're.
Thank you. Please stand by.